Hey guys, it's Mr. DeFelice. Today we're going to work on using the skill of solving problems with proportions and apply it to word problems. So we're going to see some situations where we can use proportions to help us solve. And it's a good skill to have because you can use it on standardized tests like the ACT or the SAT. So let's look at this example. A man used 10 gallons of gasoline on a 180-mile trip. How many gallons of gasoline will he use on a 450-mile trip? Before we learned about proportions, you might have solved this by trying to figure out how many gallons he could go, or how many miles he could go for 1 gallon, and then multiply it from there. But we can set up a proportion pretty easily to help us solve this problem. So the way this works, remember, a proportion is just saying that two ratios are equal, two fractions are equal. You can write them in a couple ways. We said fractions or using colons. These are different ways to write proportions. When you're solving a word problem, you're setting up a proportion with two fractions. So you always start off with the ratio that they give you in the beginning of our problem. So in this problem that we looked at here, a man uses 10 gallons of gasoline on a 180-mile trip. So it'd be 10 gallons, I'm going to abbreviate gallons as gal, over 180 miles. That's the ratio that they give you right there in the beginning of the problem. Setting up a proportion, you set up a ratio involving x. So from a proportion, you form it by setting the two ratios from steps 2 and 3 equal to each other. And you include the units of the quantities when you write the proportion. Be sure that the same units occupy corresponding positions. Corresponding means matching. In the two ratios of the proportion. So for example, here's a couple examples. In this column, these are the correct ways to do it. If I'm setting up my first ratio as miles to hours, the second ratio has to be set up the same way, miles to hours. If I'm setting it up as wins to games, the second ratio has to be wins to games. The same units are on top and the same units are on the bottom. And then dollars to ounces, dollars to ounces. Here is the way you do not want to do it. If I do miles to hours, it's got to be the same. I can't have it where hours is on top and miles is on the bottom. This is a different type of problem that we would be solving. You might do this in chemistry. You might see this in your chemistry when you do unit conversion. We're not doing that. We're trying to solve for a missing variable. So do not do it this way. Keep your same unit on top that's on the bottom when you're solving using proportions. So back to our problem at the top. If I have 10 gallons for 180 miles and I'm looking for how many gallons, so it says how many gallons, that's my question. I don't know how many gallons there are, so I'm going to put x. So I have x gallons over 450 miles. Notice my units are the same on the top and on the bottom, and then here you can cross multiply pretty easily. So let's look at some practice problems. And this is actually the problem we just looked at. A man uses 10 gallons of gasoline on a 180-mile trip. So 10 gallons over 180 miles equals how many gallons of gasoline will he use on a 450-mile trip. So I know 450 miles is the same, and x is on the bottom. So I'm looking for how many gallons. So now this is just a proportion. So now we can just cross multiply and solve like we learned yesterday. So the two values I'm multiplying are 10 times 450. So using my calculator, 10 times 450 is 4,500. I'm not going to be concerned about the units at this point. And then 180 x, because 180 times x is 180x. So from here, I divide by 180 because that's the number in front of the x. So 4,500 divided by 180 is 25. So think back to what we were solving for. It was 25 gallons. Okay, let's look at another one. A baseball team wins 7 of its first 12 games. How many games would you expect the team to win out of its 36 games if the team continues to play with the same degree of success? So remember, they always give you a ratio to start off with. 7 of the first 12 games. So they have 7 wins out of 12 total games. So I'm just going to write 12 games. How many games would you expect the team to win? So how many games would you expect the team to win goes on top. So I don't know how many wins they have. Out of, that's a key phrase there that sometimes helps you understand the denominator for a ratio. So in this case, it'd be out of 36 games. So solve it using proportional reasoning. 7 times 36 is 252. And 12 times x is 12x. Then I would divide both sides by 12. And this one you get 21. X equals 21, which we know is 21 wins. Proportions also work when you deal with percentages. So anytime you're trying to calculate a percent, like on a discount or even a tip, you can use proportions if you wanted to help you solve. So it says a recent poll suggests that 25% of seniors at Niles West plan on voting in the upcoming election. If there are 700 seniors, how many seniors are going to vote? So the given information to you is percentages. What's nice about a percentage is that a percentage is a number that's always out of 100. So if you see that percent symbol after a number, you can write it as a fraction as 25 over 100. And if you don't believe me, on your calculators, you can do 25 divided by 100 and see that it's a decimal that's 0.25. That's representation of 25%. That is what a percentage means. It's a number out of 100. Alright, so in this case, the question's asking us to find how many students out of 700 are going to vote. So 700 is the total number of seniors. So that's 100% of all the seniors is 700 of them. So we're looking for how many of that are going to vote. So that's how you would set it up. So 25 times 700, 17,500 equals 100x. And then I would divide both sides by 100. Make sure you can see that. I get 175. So that means that 175 students would be planning on voting. And think about this in terms of the problem. If you have 700 total seniors and you want 25% of them, that number has got to be less than 700. It cannot be more than 700 if you want 25% of 700. So if you get an answer that's bigger than 700, you did something wrong. Look back and make sure you set up your proportion appropriately. Remember, percentages are always a number out of 100, and then you have to figure out what is the total amount of people and then what they give you or what you're looking for. Try some practice problems that I have available for you, and then that's it for today.